So, as Howard says, this is a conversation we suggested might be useful to have, talking about how HTA topic specialists, in my case a health economist, and a research software engineer, and Catherine is from the research software engineering department at the University of Manchester, might collaborate on a piece of work. I've got a couple of caveats to make up front. The first is that this is all work in progress. The work that we're talking about here, we're probably a little over halfway through now. But that's okay, because really we want to talk to you about the how rather than the what of what we're doing. And there's almost no R code in what we're about to present. And in fact, a lot of what we're about to present is generalizable to paradigms other than R. But to introduce what we think we're doing here. So that doesn't work. Let's give it a bit of that. Let's click on there and give it a bit of that. There we go. I think a good way of expressing what we're interested in here is an observation of this fella. It's called Greg Wilson. I assume no relation, Ed. The hairline's got a little bit. He founded this initiative called the Software Carpentries, which has been influential, and it's based on his observation that the time it takes most scientists, and I'd certainly include health economists amongst that, to produce a new result is frequently dominated by how long it takes to write, test, install, and maintain software. The problem is no one's ever taught how to do it. And I certainly sympathise hard with that. I spend a lot of my time, well, the time I'm not in endless meetings, coding, and I'm a total amateur at that. No one's ever taught me how to do it. I'm an autodidact, and I've picked up bits along the way, and I've got some skills there and some bad habits. And we wanted, within this project, to try and do better than that. So, necessary bit of background, our case study is this project called Pincer, which is a complicated intervention which seeks to minimise hazardous prescribing in primary care. For our purposes, what you really need to know about that is that it's complicated from our perspective as well, because there's these 11 separate indicators, and we essentially have to model all of them. So in order to do our cost-effectiveness analysis of Pincer, we have to have 11 separate disease models, 11 separate, actually simple Markov models, but they all need to come together. So we've been, over a period of years, pulling models together in order to assess that. It started off when I first joined the project. There were a bunch of 11 models in this software triage, which some people like, as initially just a bit of QA I was doing. I made an Excel replication of one of those models, and what do you know, before you know it, I've got 11 Excel models. But that gave us one really big advantage, which is that we were able to consolidate it all into a single workbook where we could have all the analysis going on at once, and that had all sorts of advantages. The disadvantage is that it's a big so-and-so. It's got 78 worksheets and over 4,000 rows of parameters. It takes up to 20 seconds to just calculate once, and if you want to run a PSA on it, you basically leave it overnight. So we've got this workbook, and we've got this economic evaluation that we think is valuable. It's got insights to give to people who would be interested in commissioning things like Pincer, but it's inefficient and it's pretty inaccessible as well. So we got some money out of NIHR to do something about that. It's got that long title there, but we call it MedSID, which is Medication Safety Intervention. there's some argument about what the D stands for. We'll say dashboard for now. And we said in our proposal that what we wanted to do is translate the Excel models into R and do that in a relatively grown-up way. So write tests, develop classes and functions to produce something that we hope is robust, reproducible and extensible. I don't need to evangelize to you guys about how R is an attractive framework for doing that. So that solves our efficiency problem, we hope. We've still got an accessibility problem, and of course there's an obvious solution to that in our world as well, which is to develop a shiny interface. So that was the second part of our proposal, that we're going to make an interface that makes our work accessible to people who don't want to get into the nuts and bolts of it. So that's sort of the end of the evolution, but worth saying along the way that owing to some benchmarking and some investigation that Catherine might talk a little bit about, we've ended up with this dependence on HESIM in the middle as the most efficient calculation engine we could find to do things really quickly. So that's where we ended up. But to go back to where I started this conversation, alongside our two objectives to move the models into R and move the R models into an accessible interface, we had an explicit goal that we wanted to build capacity amongst us amateur coders. And in particular, we were cognizant that there are people within our university who do this stuff for a living. So we said from the outset we wanted to work with them, and one of the outputs of the project would be we would get better at what we're doing. So I'm going to hand over to Catherine now, and she's going to walk you through the implementation of that.
Thank you, Gabriel. So I'm Catherine McGuire. I'm a research software engineer at the University of Manchester, and I work in the university's research IT department, which acts as a consultancy. So we go and give software support to researchers in all kinds of areas across the university. One of them being the Pincer and MedSit project that Gabriel's team is working on. How do I get the next one? Oh, there we go. So this is a point where we shift from what we built to how we built it. As Gabriel alluded to earlier, many researchers have learned enough R to solve research problems, but have had less exposure to the software engineering practices that make code secure and robust and easy to test, review, extend and maintain. So our aim was not just to produce a package and a dashboard, but to expose and pass on the economist team to the techniques and processes used by software engineers. So a useful high-level way to explain our process, if you've not seen this before, is to use the software development lifecycle. So the software development lifecycle is the process software goes through from analysis, design, development, testing, deployment, and ongoing maintenance. So I'll talk through, just very quickly talk through some of the stages of that software development lifecycle now, as it pertains to how we collaborated with Gabriel's team. So at the analysis stage, we needed to analyse the existing Excel model and the corresponding software problem. To make sensible design and implementation choices, the economist had to help the RSEs quite a bit with the knowledge of their health economics to understand their tacit knowledge of the model. So health status, transitions, uncertainty, all of these were new to certainly me as a software engineer. And yeah, so this has likely become tacit knowledge for the people who designed it, and we're using it every day. So there was an initial stage of Gabriel talking to us a lot through the basic concepts of the model itself. And then myself and a colleague took that away and converted it into prototype scripts, which helped with our understanding of the model, and also started a process of writing some code and passing it to the economists to check that it was working as expected, and then iteratively developing and reviewing the code until we had a prototype script that we were happy with. So the output of this stage was our first prototype script, as well as a shared understanding of what the Pincer software had to do. So my understanding is that a detailed tutorial on packaging cost-effectiveness models in R was presented in a previous R-HTA conference, so I won't go into the full detail here, but in summary, for those of you who aren't familiar with packaging, the benefit of an R package is that it gives the project a standard structure, clear places for functions, data, tests, and documentation. We chose to develop an API within the package because the dashboard and the other code needed a reliable way to call the model, and the economist input here was to define what inputs and outputs the model needed to expose. We chose, in the end, after some investigation, some benchmarking, to use S3, which I'm sure many of you are aware, is the simplest object-oriented system in R. Object-oriented programming is a way of organising code around things, in our case models, rather than just writing a long sequence of steps. S3 in particular lets us treat each model as the same kind of thing, while still allowing model-specific code where the economics differs. This allowed the economists to work towards adding new models to the package code themselves by following a fixed pattern. And using S3 as opposed to R6, which we did look at as well, meant there were fewer new concepts for the economists to learn, and I've got to be honest, for me to learn, than there would have been with R6. Another design choice that we made, as Gabriel mentioned, was whether to write more of the model running code ourselves or to build an existing package, or build on an existing package. So we assessed whether HESIM worked well as a software. So the major thing there was how fast could it run. And the benchmarking suggested that the HESIM approach was around 10 times faster than developing things in base R. And then the input of the economists was whether HESIM could correctly represent this specific Excel model. For example, its states, transitions, costs, and utilities and all that. Once we got to the development phase, once the RSEs had set up the package structure, the economists first wrote the model logic as interactive R scripts. The RSEs then moved that logic into the package pattern, so a model constructor, model-specific S3 methods and tests. And then as the pattern and the structure became more established, adding a new model became a repeatable process, and the economists were able to start adding models into the package themselves. One thing that was good about this project in particular, in terms of testing, is that we know the truth, in the sense that we have a reference version of the model, the original Excel model. That means we can use comparison tests which check whether the R model reproduces Excel-derived outputs. We also use unit tests, model structure tests to check that the models are created with the expected S3 classes and structure. We look at the test coverage, and we use the R CMD check, which is the standard R package check. So these automated checks help catch coding errors and protect against accidental changes in the future, but they don't obviously replace the economist review of assumptions, input values, and model logic. Onto the kind of tools and the processes that we use beyond the software development itself. One of the main tools that we use to manage software projects in research IT and in this project in particular is GitHub. So GitHub is widely used by researchers as a version control tool and a place to save code and keep history and share it, often on a single branch. But this slide summarises how GitHub can support collaborative engineering, not just saving and sharing the code. But I'll use an example now to illustrate this. So this is a GitHub project board. This is this is where all the tasks for the project go. So in agile teams, the work is broken down into small, visible tasks. Those tasks can be added to the GitHub project board, and you can see I've added an example task there to update a README at the bottom of the to-do column. And then as the project progresses, tasks can move through stages from to-do to in progress to in review and done. So this makes progress visible in real time to everyone with access to the board. Each unit of work is developed on a single branch, so the main code is never changed. And this means you keep a functioning version of the software while changes are being developed. I have missed a slide here, but you can click on the task and open it, and it has a link there to create a new branch associated with that task automatically. So then once you've finished making changes to your code on your separate branch, you raise a pull request. And this is a request to merge the new work into the main code. It shows the changes and gives a place to review, for your colleagues to review and approve them. This is an example of part of a code review from another task on the Pincer project. Code reviews give the team a structured place to discuss changes before they become part of the main package. So it's a place to raise any issues that you think with the here, for example, the test coverage, or if you think there might be any breaking changes in the code. After a review, automated checks can also run in Research IT. GitHub is configured to check things against departmental standards, so things like licensing, naming conventions, and we also enforce a compulsory code review before the changes are merged. And if the checks don't pass, the changes cannot be merged. And then once the reviewer is satisfied and the reviewed checks are passed, the branch can be merged into the main code. And this gives the team a control process, so task, branch, pull request, checks, and merge. So finally, my reflections on working on the Pincer Medicine project. As a research software engineer, it's easy for me to go into each project and just treat it like a coding task. But particularly in this case, the software structure only works if it preserves the health economics logic. So the RSEs brought the packaging structure, the testing, the code review, and the maintainability. And the economists brought the model logic, assumptions, expected outputs, and the judgment about whether the outputs made sense. From my perspective, the project worked best when we treated these as shared responsibilities. The economists didn't just hand over a model to be coded, and the RSEs didn't write the software in isolation. We built a repeatable structure and a process together, tested it against the Excel model, reviewed it, and moved towards handing it back to the economists to maintain themselves. So the main lesson that I would take away from this collaboration is that subject matter experts are crucial in the development of research software. And for me as a research software engineer, the Pincer MedSid project has been about learning how the collaboration with the subject matter experts can be best handled. hand back to Gabriel now.
Thanks, Catherine. Just a few closing thoughts from me about how all that has worked. So the advantages of this structured process we've gone through are sort of the obvious ones. Everything we hoped for, I think we've got. We have every confidence that this process has been much more rigorous, will be more transparent, is certainly more reproducible. We hope it will be extensible, and it's definitely quicker. That 8-hour PSA, we think we'll probably get down to under 5 minutes in our implementation. It's good that the whole package is much less dependent on me as an individual. I'm the only person who really understands that Excel workbook. And it's quite hard to share that knowledge with other people, whereas in a documented package, which multiple people have contributed to, that problem goes away. I went into this project with a degree of imposter syndrome when it comes to my R coding, but it turns out it's all right. Actually, quite a lot of my code has been incorporated verbatim in the code base, and that works fine. A real advantage is that it lends itself to open sourcing in that way that we're all enthusiastic about. We did publish one paper earlier, a couple of years ago, looking at a subset of these models in some regard in the BMJ. And they wouldn't publish it unless we made at least a cut-down version of our Excel tool available. And that feels really uncomfortable. It feels like putting your dirty washing in public. Whereas I'm totally happy that when we finish this, everything will be in a freely available repository. And that feels natural in a way that sharing your Excel doesn't. So what would I flag as disadvantages? Well, I have to confess that it hasn't totally weaned me off the bottle. We've heard a couple of times today already about packages and solutions to R modelling that still use Excel for like a parameter input bit. That's quite a common use, and I think it's a good use case for that. But also there are the model we're going to end up with in R is a little bit less sophisticated in some ways than the one we've got in Excel, because it's really easy just to chuck switches in and go like, oh, what if we do this, and have a new scenario. And that is not necessarily more technically difficult to do in R, but doing that and thinking about how a user's going to get at it and make it repeatable is much more complicated. Despite a reduced reliance on me, I'm conscious that I'm still a bottleneck in this development process. So the early career researchers who are working on this project, the economists, are doing good work at having a first go at moving some models over into R scripts. But they always end up with me having to debug them because I'm, like I say, the only person who really understands bits of it. And so I'm conscious that there are times when I'm holding the project up. It is undoubtedly true that this level of discipline is more work and more time. I've just been doing some reporting to the funder about this, so I can tell you that Catherine and her colleagues have spent just over 820 hours on the project so far, and that's used up about 2/3 of our money. So there's real time investment in that, and under other circumstances where we weren't being funded to go through this process in quite a painstaking manner, I don't know if we would have had the resource to do it as thoroughly as we have. But to close on the thing that I've got most out of this project is I went into it hoping that I would learn a load about coding in R. And I've learned bits and pieces along the way that's been useful. But by far the biggest takeaway for me is about collaborating with a multidisciplinary group and having the kind of processes that Catherine was talking about in place, such that everyone's accountable to everyone else, everyone knows what's happening, there is a transparent path through your development work, and that's the thing that I'm taking forward into my other work to a much greater degree than any particular coding trick I've learned along the way. That's it. Sorry, Catherine, I haven't put your contact details there. That's just my old end slide. Yeah, but that's us done.
So we have, so before we go into more of the discussion questions, are there any questions to Catherine and Gabriel from the audience? Michael, I'll give it to you.
Talk loudly if you like.
It's okay, I got that. We're good.
Yeah.
So one of the things that I think a lot of people here are wondering is, how did you convince the funder to give you the money to do it? Because I completely agree. Having someone who is specialised in this is incredibly powerful, but I have seen several projects, not necessarily in health economics, but in general in the university space, where it's difficult to convince a research council that this is actually a worthwhile use of the money. So I'm curious of your thoughts on it from both of you. How do we convince the research councils?
So I can give you an answer to that. We were slightly advantaged in this case because what we were doing came out of that history that I was talking about, and we had the large program grant from NIHR to develop all that stuff, including the big Excel model. Then what we did is submitted a proposal for a program development grant, which is a little bit of top-up money to do extra things that helps with the dissemination or whatever, the extra bits that your program grant might need. So in that respect, it was maybe an easier sell than if we were starting from a blank page. But I think one of the things that we successfully argued to the funder was this capacity development thing, to say, it's one thing to go to them and say, we want to use our really good professional software developers because they're the experts on this. But I think we were successful in selling to the funding body, we want to upskill our enthusiastic amateur economists by exposing them to grown-up practices. Have you got anything to add?
No. I think you covered it all, okay.
Any more from in the room? I've got a quick one from online for you. So how did you find using GitHub, Gabriel? And was there anything you found helpful in upskilling?
Yeah, so everything that Catherine's talked about, like the people in Catherine's presentation, I used GitHub before as a version control repository. I didn't use it as a collaboration tool. I find the project board incredibly useful, especially I've had projects before where we've had some kind of Kanban board where we're trying to move things around, and it either sticks or it doesn't, and most often it doesn't. What's brilliant about that, the way that works within GitHub, is that those tasks are linked to issues, are linked to branches, are linked to pull requests, are linked to updating your development, and so that workflow becomes sort of self-perpetuating and becomes something that you not only use grudgingly, but come to totally rely on.
There's another question online about whether you've used AI for red teaming, for compliance checks, checklists, coding, unit testing.
I'm going to hand that this way, I think.
So is the question about using AI to develop tests and things, or is it about is it part of the development process, or is it integration into the software itself? Part of yeah, for sure, because it's just become part of. It's just become another tool that software developers use, and I think there's a right way and a wrong way to use it, and I think you need to. Because anyone can get AI to build them a software product, but you have to know the right questions. You have to know something about what you're building to ask the right questions, to know when it's giving you a sensible answer, and to know things like don't put sensitive data in any kind of AI tool, or that kind of stuff. So for sure we use it. I like to think in research IT we know how to use it well. But yeah, you have no choice really, because everybody else is using it. So you've got to get on board.
Within that, you mentioned how there are compulsory code reviews in everything we push to GitHub, and this has changed over the course of the project in just a year. That we're having the Copilot reviews done on everything we push really. And that's just an extra person reviewing the pull request, and it always finds things.
A lot of things that aren't actual problems as well.
Oh yeah, it does that.
This is where you need to know. You need to know your subject matter to look at a GitHub, a Copilot comment on a code review, and know, well, I don't need to do anything about that because it's just talking rubbish.
Yeah, worth saying that we've got a sort of sandbox area of our repository that won't be part of the final release at all, but has been where we've been working through things. And actually, yeah, you get loads of Copilot comments on that, and you just go, this is nothing we need to worry about in the long run.
Okay, so I just have one question at least for you about what's written on the board, and Gabriel, you alluded to the definite cost that's needed for this formal software development, and Michael, you talked about getting funders to spend money on this stuff. So how do you balance the trade-off between good programming, good engineering practice, and more effort on your model design, parameterization, scenario exploration? Because Gabriel, you did mention that you didn't explore scenarios as extensively as you previously would because you were worried, how is someone else going to do this? How is someone else? So it does restrict you a little bit in exploring the conceptual space or the health economic modelling concerns.
Yeah, okay. I've got a bit of a cheats answer to that, which is that in this instance, the model is conceptualized, it exists, and it's a technical project. If we were in the same position but starting from scratch and having to conceptualize and parameterize a model, then there definitely would be an important trade-off there. But then I guess I would also like to say that one of the advantages of the kind of framework we've adopted here is that I've had, while not perfect, a better appreciation of exactly where I am in the project, because it's all laid out, and a better appreciation of how much resource I have to spend. And so maybe in this kind of paradigm, you can make those choices a bit more consciously, because you know what you've got available to spend. And that's maybe a bit more done on hunch when you haven't got that kind of structure.
So obviously related to that question is, how about teaching? How do we change our teaching to bring in more of this software development versus teaching them health economic modelling or health economics?
Yeah, I've become a bit opinionated about that in a way. In that, I mean, hands up if you spend all day coding. Hands up if you have any kind of qualification in coding. That's it.
There we go.
And like I hire people fresh off health economics masters who've spent a whole module doing applied microeconometrics, and we never use that. It would be much more useful to 98% of economists' workload if they spent that time learning something like the carpentries, learning the processes behind code development, and not being enthusiastic amateurs. That would be a big paradigm shift in the way that those courses are taught, but it would, if we imagine that they exist to skill people up for the workplace, then it would be much more useful.
Just give a bit of a plug for research IT departments in universities. Is that what part of our job is to offer free training to researchers across the university? I don't know whether Sneha and Dodo. So we did, we do R, we do HPC, we do all kinds of stuff. We do GitHub courses and that kind of things. So if your university's got a research IT department, that's a good resource to use for your postgrads and whatnot.
All right, fine. It's making me work.
So I don't know what it's like in other universities, but the University of Bristol in the last couple of years have introduced, shall we call it X with computing, where it's physics with computing, chemistry with computing. But one of the issues that tends to happen in this is it's fundamentally comes down to hard science with computing. Every other subject, you're on your own. I think a lot of that comes down to the computing that they're looking at tends to be more high performance computing, but it feels like this is where there is possibly scope to have degree courses that are actually health economics and computing, epidemiology and computing, where because the computing aspect is actually a centralized course. Everyone in all of those subjects does the exact same course to pick up the skills. So I'm wondering if that's something that could potentially be moved into this area, or possibly even expanding their courses and stuff. And for those universities that don't have these courses at all, try and convince someone to start making it. But that's a big barrier. So I appreciate that. But what do you think about like the sort of centralized courses almost ran by the computer science department in a way?
Sounds brilliant. As I've said, a lot of what I've learned in this project is not really R-specific. It's just about learning the ropes. I mean, would you even consider yourself an R specialist first and foremost? You wouldn't, would you?
I mean, in a sense, really, the language doesn't matter so much as the processes and the ideas and the concepts. And based on working as a research software engineer and working on loads of different projects all over the university, I think software engineering and AI, it just infiltrates all kinds of research now. So, I mean, I would say it's just a fundamental skill that all undergraduates should be learning, probably, if they want to go into any kind of research, especially in science.
I have a comment more than a question, perhaps, and it links back to something that you said, Gabriel, earlier on. I think we must be a bit wary of not going all the way to the other side. Maybe we don't need the person, the one individual that can be a coder, an economist, a statistician, and somebody who's actually able to communicate their result to nice. The point is that this job isn't just one person. You need the economist to inform what the model would be. You need the statistician to actually run the model. And you need somebody who is proficient and professional in terms of coding to support the general structure of the actual work that gets submitted in the end. So I agree that we need to upskill the whole community, and that's part of why this exists. But maybe the holy grail is not the one person that can do everything, because I don't think there's any such thing.
So I guess very much building on from that, as a research software engineer, what are the skills that you think would really help in people coming to you? Is it actually understanding the language, or is it understanding how how coding more generally works, or what's happening under the hood when you write a statistical program?
So he's talking about working with researchers in general or working with health economists?
I don't know how generalised it is, but okay.
Project is building a website for a history department. So it's all kinds of, yeah. So I guess you're working with people with different degrees of knowledge. Gabriel's very knowledgeable in R, probably more so than I was. We work with a colleague, Tony, who's very very knowledgeable with R. But I think it's the most of the time it's the software engineering practices, the best practices, especially if we're working with kind of more sciencey leaning people who've got a bit of coding knowledge anyway. If I'm working with someone who's not a scientist, it's usually just build the thing and then leave us alone. So the question was about what skills that people are looking to learn on.
For you, when people come and ask, especially in HTA, what's your ideal candidate? Is it someone who is good at art, or is it someone who understands sort of software practices, or is it someone who understands sort of the statistics really well? What's easiest for you to work with? Because that's the skill that we should be focusing on.
So it's been really good working on the Pincer project because so Gabriel and his team are really kind of they want to learn. So sometimes you'll work on a project because we use all these tools every day in research IT, whether I'm building something for health economics or I'm building something for the history department. The degree of interest from the researcher varies. So it's you just want someone who's interested in adopting these things. Trying to force things that people aren't bothered about. It's frustrating because we've got to use them anyway. So yeah, it's been nice because, and we've learned a lot from the health economists too. I've enjoyed learning all about kind of the subject matter side of things, and
That's got to be a bit double-edged, though, right? If I can imagine it comes with some frustrations as well if you've got someone who always wants to get their hands on things. But as I said, we deliberately conceived this project as something that would have didactic value for the economists in my team. And I feel a bit sorry for Catherine and her colleagues that what they've got out of the knowledge exchange is something that isn't going to be very useful for them in future, whereas we've hit the jackpot.
This is a question that's maybe quite specific to this use case, but do you think it's sort of easier or takes less time to sort of take a coder and teach them health economics principles, or take a health economist and teach them coding principles? I sort of I suppose where this question is coming from, sort of in terms of increasing the use of coding within the industry. Is it a case of not teaching the industry how to code, but instead teaching coders the industry?
So I've not been fortunate enough to have a pure coder knock on my door in that way, but I have been saying for years that quantitative smarts are the most important thing, and that if you give me an early career researcher who's dead clever and dead good at sums, then I can teach them everything they need to know about health economics quite quickly. If, on the other hand, you give me someone with a good master's degree in health economics, but who sort of skirted the quantitative bits along the way, I have experience of finding it very difficult to get useful work out of those people. Just to follow, I'm sure the same is true of coding, that if you had someone turn up who had those really good generic skills, wouldn't take long to make a model out of them.
Okay, so just because we need to have one last question? Okay.
Quick one. I just noticed on your slides that you showed your code in Jupyter Lab, and I'm sure everybody here that presented today showed RStudio. So I wanted to ask about that.
So in terms of the different environments you might use to develop, is that the question? So
I've never seen that presented in Jupyter Lab. I've only seen people who use Python.
oh, okay. You can just there's like an add-on you can get to use R and Jupyter Labs. That's just my preferred thing because I'm a Python developer really. So I just want to do everything in the tools that I like. So I'll just find a way to use R in the tools that I like. But I think there's some kind of minor conflicts because you use R Studio. So we are both using our preferred environments, but I just try and make things generalizable between environments.
Yeah, there's been a moment where Catherine set out a really helpful document about how to handle a pull request for me and the economists. And it's all sort of console-based stuff, and I just had to respond going, you know there's a button for that in our studio. You can just, that's easy. But yeah, I mean, and you also like using that kind of environment to be in the same way you can with R Markdown, with combining bits of code and observation as you go and building yourself those notebooks, right?
Okay, thank you. Let's thank Gabriel and Catherine again.